Good evening, my YouTube viewers. It's Crystal here. I'm just here because I wanted to give you a code review of what I've been doing in a statistics course on YouTube. In this statistics course on YouTube, they're giving you the code in R, which is a programming language written for statisticians. But what I've done is I've converted the code over to Python because Python is what I'm more familiar with. But I'm going to give you the code in both Python and R, and then you can make your mind up which programming language that you prefer to use, Python or R. So the first thing we're going to talk about is Python, and I use Google Colab to create the program. I like Google Colab a lot because it allows you to type your program into a cell of data, and then underneath the cell of data, it will give you the information underneath each cell. So that's something great about Google Colab that I really like. The only thing about Google Colab that I really don't like is that it doesn't have a decent undo function. So you have to be really careful not to accidentally delete or overwrite code. But if you delete or overwrite code, you can go into the save history, and there's a possibility that you can get the code back after you have gone into the save history. So now you know a little bit about Google Colab. What we're going to do is we've written a program to create charts. And the first thing that we're going to do is we're going to import our libraries. So we're going to import NumPy as NP, Pandas as PD, Matplotlib .pyplot as PLT, and Seaborn as SNS. So NumPy is a numerical computation library. Pandas is a data processing library. Matplotlib is a graphics library, and Seaborn is a higher level graphics library written on the back of Matplotlib. So after we have imported the libraries that we need, we're going to load the file, and we're going to use Pandas to do that. So data equals pd.read underscore CSV, and then this is the web address for the site for the CSV file that we're going to be using. And it's a CSV file about crime rates. But because this CSV file has a lot of columns in it, what I did was I set it up so you can see all of the columns instead of just a few. And so this CSV file has 51 columns. Sorry, it has 51 rows. The reason why it has 51 rows is because 0 is the first number in Panda. So what we wanted to do is I wanted to look at the shape of this data set, and it's 51 rows by 36 columns, and we wanted to find out the unique values in Census 4, and that's Northwest, Midwest, and Southwest. But what I'm going to do here, I want to see the unique values of something else as well. And so I'm going to rerun it and hope for the best. So we're looking at the unique values in Census 4 and the unique values in Dompo culture. So in my video yesterday, we created a pie chart. We showed you how you can create a pie chart with one line of code. Data.groupby, census4.size.plot, kind equals pi, auto% equals %.2f, And so you can see we've got our pie chart with the percentages in it. And now what we're doing is we're making a bar chart. So with the bar chart, it's data.group by census4.size.plot kind equals bar. So you can see we've got a bar chart instead of a pie chart. Now we're making a Pareto chart, and a Pareto chart is one where the highest value is the first position, the second highest value is the second position, the third highest value is the third position, and the least value is the fourth position. So that's the Pareto chart, and it's data census4.value counts.plot kind equals bar, and that's your Pareto chart. So now we're making a Pareto horizontal chart, and again that's one line of code, data census4.value counts.plot kind equals bar H, and that's a horizontal Pareto chart. Now we're looking at a stacked chart, and again that's one line of code, pd.crosstab data census4, data dom pol culture dot plot kind equals bar, stacked equals true. So this is a stacked chart, and you can see that it's stacked on census4 and dom pol culture. And then we've done the same stacked chart, except we stacked it on dom pol culture and census4. So we just changed out the column names. So now we've got a side-by-side chart, and that's AX equals SNS dot count plots, data equals data, X equals census4, U equals dom pol culture. So now we've got a side-by-side chart. So we've got a side-by-side chart where we swapped out the data, the census4 and the dom pol culture. So you can see that. Now we've created a histogram. I've created a lot of histograms in my work. SNS.histplot data v crime 90. So basically you're looking at the crime rates for 1990. And so we've created a histogram, but we give it 25 bins. And then so it's just a little bit different histogram. And you can do it that way. So now what we're going to do is we're going to do a stem leaf plot, but in order to do a stem leaf plot, you have to install a library called Stem Graphic, because this is not automatically installed on Google Colab. So we do a stem and leaf plot, import Stem Graphic, stemgraphic.stem_graphic data vcrime90. So you're doing a stem and leaf plot of the column vcrime90. And so you can see it looks like the stem, and it looks like an upside down stem and leaf really, but that's what they call it, a stem and leaf plot. So that's it. That covers it for this code in Python. So now that we've covered the code in Python, what we're going to do is we're going to look at create the exact same things in R. So what happened was the code was in R and I converted it to Python. So this is all the code. So the code is on one page of code. I'm using Replit because Replit is a free online interpreter compiler, and I like to use free resources, and I like to use online resources, which is why I used Replit, because I don't really want to install software on my computer if I don't have to. So what we're going to do is we've got the code here. We load the data set, data equals read CSV and read.csv, and it's the exact same web address that we use in the Python. Attached data, names data, summary data, We're going to create a pie chart. We're going to create a bar chart. Create a Pareto chart. We're going to create it's still a bar chart, but it's a stacked bar chart. We're going to create a side-by-side chart. And then we're going to create a histogram. And then we're going to create a stem and leaf chart. So I'm going to run it. And then you see it's done all that stuff. And at the very bottom, you've got your stem and your leaf, which is what I'm accustomed to seeing. On the Python, it looks to me like the stem and leaf chart is upside down. But this is really what your stem and your leaf chart looks like. And then if you want to look at the other graphs, what you have to do is you have to go to the PDF file. And so the PDF file creates a pie chart, a bar chart, a Pareto chart, a horizontal Pareto chart, a stacked chart, and then another stacked bar chart, a side-by-side chart, and a histogram, and another histogram, and another one. So that's it. The thing that I don't like about R, and I don't know if you bought an R compiler and you installed it on your computer, if it would come up in a PDF file like that. But I'm not really crazy about the charts coming up in the PDF file. I like the charts coming up in the program, which they're not doing that. So now you've seen how we do it in Python in Google Colab, and you've seen how we do it in R and Replit. So you can decide which way you like best. I mean, I like all the charts and everything on Python better because you can type the code into the cell and then the chart will come up right underneath the cell. But I do say that I like the stem and leaf chart better in R because it looks more like a stem and a leaf than this one here in Python. But I'm just wondering if I'm going to try this. I'm just guessing it. No. So I'm just wondering if just say stem and leaf chart ascending. see what we can do. Okay, stem and leaf chart, Python, stem and leaf plot, let's see highest value at bottom, see what it says. There's another one. It doesn't look like it's allowing you to make it ascending. It gives you the, it doesn't look like it's, puts the highest number on the bottom. They give you how to do a stem and leaf chart, and Matplotlib, but that's not it. So I guess what I can do is I can try to research it on my own and see if I can figure out how to get it to reverse, because it says data equals vcrine. Or I could say, I'm going to research it on my own, and then I'm not going to waste any more time with this video. But what I'm going to do is I'm going to research it. I'm going to try to get the highest number on the bottom and the lowest number on the top to make it look like a proper stem and leaf chart. I'm going to try this. I'm just going to give this a try. I don't know how it's going to work, but we'll see. Sort values. Give it another try. But it's still not working. but it's still not working. It puts the highest value up top and the lowest value on the bottom, and I'm not sure how to do that, how to reverse it. So I will have to study it on my own because I've been talking for 20 minutes. And if I am able to reverse it, I definitely will make a video and a blog post on that as well. So I would like to thank all of my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. Thank you very much for watching my video. Let me know what you think, and I look forward to making more code reviews for you in the future.